Good afternoon. Can everybody hear me all right? All right, good. Hi, I am Ronald Pulliam. I am a senior automation engineer at Flexware Innovation. What that means is that I tend to deal with the manufacturing world, and not using Python. I do a lot of PLC work and various other things that don't deal with Python. So what we're going to talk about today, in conjunction with engineering itself, is a lot of what I do for fun and for the around the edges cases of what I do. All that to say is that my Python isn't clean code, but I will show it to you willingly, allow you to pick it apart at your leisure, because the point of the talk isn't that I write great code. The point of the talk is that I am an engineer, and so can you. Engineering is something that we can all, whether we went to school for it or have it in our title or train specifically for it, it's something that we can all participate in. Today, we're going to go over these topics. And I'm going to try to speed through some of this. 30 minutes is probably not enough time for this full deck here, so I want to really get to the end part where we talk about different projects or the fruit of my labor. But to start off, I want to talk about the promise of technology. When I was a freshman in college, the department chair of the electrical engineering department was teaching one of our intro classes, and he said something that surprised me, something I hadn't heard before, and that was that around the turn of the 19th century, there was a promise of technology that would enable people to work less because of technology. I know in the world today where people are working 50, 60, 70-hour jobs, this might seem like a far-fetched idea, but it was Keynes in 1930 that really formalized this, and he's an economist, and with the idea that people would be working 15 hours a week. There's been a lot of fights to make that a reality, not the 15 minutes, but the 40-hour work week or the 8-hour work day. A lot of fights happened in, I don't mean physical fights, a lot of struggle happened in the Chicago area to make 8-hour work days a reality. In 1940, the law that was passed in 38 officially became law, I believe by Roosevelt, to have an official 40-hour work week. But technology should be helping people live better lives. And as the role of the engineer, and I don't actually mean that kind of engineering, but hey, train engineers too, is to develop applications, to develop technology, whatever that means to you, in the real world, physical, that helps people. What I really like is the new motto of our company. We exist to unleash the potential of technology, freeing people to focus on what's next. And what I really mean by all this is that there are specific mottos that I believe that every hacker, every engineer ought to struggle towards. Doesn't mean the exclusion of other things. For example, destination before journey. The journey is great. We want to learn along the way. But as a hacker, our goals are to get to the end. Voltaire said the perfect is the enemy of the good. I believe that the role of the hacker is to work towards function over form. Design is good, making something pleasing to the eye is good. But as a hacker and as an engineer, we work towards something that is useful, something that can impact lives and impact our day. And simplicity over elegance. And as you'll see in my code here in just a second, I I try to practice this as well. My code's not elegant, but it is simple. Simple for someone to come along and look at, to read, and to augment themselves, to implement themselves. So in our labors to engineer, to design, to develop new products and new systems, we ought to work towards designing for other people and not just for our own means. So tools of the trade. And I am zooming right through this, so hopefully you're gleaning a little from the slides themselves. We use Python. Python is a great tool. I also do a lot of this with microcontrollers, and so I want to talk about a little bit of Python for microcontrollers. Some of you might have seen this at a previous talk that I gave at AutomateConf. It is a re-implementation of Python, written in C, of course, for hardware, for microcontrollers. And so you'll see some projects that I'll present that are Python, and some are actually MicroPython that are living on the hardware, on the metal, that implements the full, well, not the full stack. It's unlike Python, where the batteries are all included, leave a lot of the libraries out because we're working on space-limited hardware. You can see here one of the very first pieces of hardware that MicroPython ran on. It was developed by Damien George when he was at Cambridge. Launched via a couple different Kickstarters, very successful. But this is the Pi board. It was the first piece of hardware based off the ARM Cortex M0 chipset. Actually, I think this is an M4, but it's been ported to a lot of different boards here that you can get your hands on pretty inexpensively and play with Python on hardware yourself. So you can try to replicate maybe some of the automation that I've done in some of the projects you'll see, or come up with your own. So. Let's talk about the project. So the fruit of my labor. This is really where I want to spend some time showing off some of these projects. I have 4 for you today. Some of them, once again, are purely Python. This is one that is just Python code. It's not hardware, but we'll get to some hardware as well. So. And of course, it's most of the stuff I do is open source, so you're able to go take a look at it, copy it, use it for your own projects. So you can grab this off of GitHub should you want to do that. Here's the problem. I have a spread out family. We're in various places. We want to do something for the holidays, give gifts, you know. We traditionally, everybody buys for everybody, and that's, as we all know, not only expensive, but it's kind of a pain because you just don't know what everybody wants. So we decided to implement this year a Secret Santa program. Well, how do you do that when everybody's in various places? We're not on the same place to draw names out of a hat. Also, where there's rules that we have. Right away, my family wanted to implement rules like my sister didn't want to accidentally get her husband chosen for her. She doesn't want to buy a present for him for the Secret Santa. She'll, I'm sure, buy a present for him at some point. But likewise, I don't want to buy for my wife. I don't want to buy for my kid. For the Secret Santa, that's a time for the family to give to each other. So we had a lot of rules that we wanted to implement, and we wanted this to happen anonymously, and I wanted to participate. I could have just, you know, divvied up names and did the matching, but then I don't get to participate in the fun of the gift giving. So I thought, well, this is a perfect tool, or a perfect problem to develop a tool using automation, using Python. So that's what I did. So one of the first things that you have to do is set up the rule set. So this is how I envisioned it. I'm sure you can envision other ways to do it. This is a CSV file with email addresses of all the different participants on the left column, all of their names on the far right column, and I transpose that into the headers of the columns in the middle, and then you have a matrix. Zeros are this gift, this matchup is not allowed. If you can see there, in row 2 and column 2 there, test 1 and test 1, you can't give a gift to yourself. But also, test 2 is that person's spouse, and so they don't want to give a gift for the spouse. So you can see that there's a rule set there, and they can get complex, they can get simple. You can see at the very last row, test 8 can give a gift to anybody, can be paired up with anyone, doesn't matter, except for themselves. And so that's how I envisioned the rules to be implemented. This CSV gets read in. So I created a class called the Santa class. That Santa class has different attributes like the email address that gets read in, their name, their rule set, so that row of rules. Their Santee, who I guess I might have called this a Santa-er and a Santa-e, but that's the recipient. Once again, this goes into my go quick, get stuff done. I might have thrown a label in here that maybe doesn't make a whole lot of sense. That's okay. We'll just keep on rolling with it. I used it throughout, but I'm getting to the finish line. So, and then a convert function here just to read in that to take all those zeros and ones and turn them into true and falses. Maybe that's not the Pythonic way to do it. I don't know. But I'm getting towards the end. So, and of course there is, this is where the random selection happens. So that's part of the class. So I will call the specific, and you'll see in a second, I'll call the specific Santa and have them identify a random choice of all those columns that are possible. That's pretty self-explanatory. I look for a random column and I return it. Yeah, and like here, I have, if it didn't work for some reason and it took too long, I have a timeout. There were no available options or something happened with that random. I say an error happened, so I mark that as true, and I'll use that later on in the program. So this is where I'm reading in, and this is going structurally through my program right in a row. So this is where I read in the CSV. This is outside of the class. This is the first thing that actually executes in my code. Reading the CSV, reading the rules, and create my Santas, all the Santas, in a list. I also read in the headers from the top there to be my list of Santees. And then I think that's it for here. The bottom is creating all the Santas. I iterate over that list of Santas. I go look for a random choice. I see if that random choice is a legal choice. And if it's not, I reject it and go looking again. And if that's not a legal choice, I reject it and go looking again. So I have to have a timeout on this, right? Because that could take a while. So if it does time out, error happened is my variable name because it's just what I thought of as I was going through, and that's true. And then if it's a success, I store that into who's the Santee for that Santa, and I move on. So send out emails. I don't know if you've sent out emails, and if you're using a Gmail account to send out emails through SMTP, you have to go in and configure some things, but it's pretty easy. And I'm sure I just copied this code from some website, like we all do, because I have no idea what those first three there happened if it didn't error out. And then you can see some commented lines. So I run this, of course, so the way I write code, likely the way that you write code, is I write a line and test it, write a line and test it. And so what I don't want to happen is a bunch of emails to go out ahead of time saying that this is your Santee. But you can, so I comment all that code and run the code over and over with that commented. And then the one time I actually want it to work, I uncomment that code. And then that's the line that actually sends out the emails. And you can see there that it's a really simple message. And I just embed into it the different strings that are taken from the Santa class, like the name of that Santa and the Santee's name. I'm assuming that they have a way to know who that is when we're family members, so I don't send the email address along, I don't send other data, so. And then that's it. So pretty straightforward program, fairly simple. I don't do any complicated error handling, really. I do much, because this is just something that I run, I see if it works. There is the very real possibility that that whole timeout happens, because there's no, like, you get to the last Santee and there's no, like, option, or you get to the last Santa, there's no Santee available, and it just borks. And you go, oh, okay, well, I pause there for you to enter in your credentials to your Gmail account. So that's not stored in the program, so it won't send the emails if it borks because you don't even get to the point where it asks for your password. So you just kill the program and run it again, right? And then if it actually gets through the whole thing this time, because it's randomized, then you're like, oh, well, hey, it worked. I'll put in my credentials and I'll send off all the emails. And we did this year. So it worked out great. And no one had any weird duplicates or anything. I did run it a few times just logging to the screen, but I comment out that code when I run it for real because I don't want to know what all this stuff is. Now, it's true, I could cheat and just go to the sent box in the Gmail account I'm using, but at least there has to be a level of trust. You know, I wrote the code, you know. Going along those same lines, some of you might have seen this one. I have presented this one previously. Christmas time again. So you have plenty of time if you want to implement these yourself. So go out there and get code and get hardware and re-implement this, because this is all open. So you can find this on Hackaday. Hackaday.io is a place where people share projects, a lot of time hardware related. I encourage you to go check it out. Hackaday.com is a great blog service where you can see a lot of interesting hacks and technology. If you don't know about it, check it out. They also have a great podcast. Anyways, this is my Christmas tree watering system. So what's the problem here that I'm trying to solve? Christmas trees, if you haven't seen the videos, go up in a flash if there's a spark and it's a dry tree. So you got to keep your Christmas tree watered. I hope all of you water your live Christmas trees if you have one. If it's plastic, I don't know. Don't do anything. I don't know how to take care of one of those. I guess you dust it once in a while. I don't know. But we use live trees, and getting underneath to water the tree is a pain, right? So there are solutions out there that like bring a hose up, and there's like a funnel, and you can like water it without getting underneath. But I'm a hardware guy. I want to build something with a pump and a reservoir of water and everything. So that's what I did. I had this old watering, you know, the teeth water pick thing. I switched to floss. I prefer it, and I recommend if you're not flossing or at least using a water pick, your dentist wants you to do that. So go ahead. Gingivitis is no joke. So I had this one left over. I didn't like it, so it had a physical on-off switch, and so I automated the turning of it on to be the pump to deliver water to my Christmas tree. The way I did that is by this little device. It's a $5 device. It has a relay inside of it, power in and relay out. So, and it has a little microcontroller in there that you can flash with MicroPython. So you can program this with Python and do essentially whatever you want it to do. It does come with firmware. It works out of the box. It's not Python firmware, it's C, I assume. But why use what's stock when I can change it and do whatever I want? So luckily it also had a header that's on the board itself that I can, it had spots for a header, a little 5-pin spot. So I soldered on a header. I communicated to it with a little device that translates from USB to serial and reprogrammed it with MicroPython and put some code on it, and you can see the green cable coming out of the right side of it. That's actually some inputs. So I developed, let me see if I have a picture of it. Yeah, up there over to the right, I developed my own level sensor, which is just some all thread going down into the water reservoir where the tree would be, the Christmas tree stand. And there's 2 rods that are the same length and one that's a shorty. The center is a common, and so if I get continuity between the 2 long ones, or actually if continuity is lost, I know the water level will drop below those. And then that would start filling until you get up to where there's continuity between the middle one and the shorty, because then the water's all the way up to it, right? And the water creates an arc between those. And I'm just switching ground. I'm not switching power or anything. So that's just a little homemade level 2 level sensor, and then this is the code. This is how you interact with hardware using MicroPython. You import a machine library, and then you define your pins, the pin numbers. I had to look up online, like, this header, what are the pin numbers to this thing, and what do they do? And so I labeled them specifically of what that does, though I'm using TX as one of my levels and pin as my other level. I just didn't name them like level low and level high. And then this is the whole code. So it's a state machine. I have a truth table essentially, right? You have 2 bits on and off. So you have off, on, off, on, right? And so you have, and that's, convert that to decimal, that's 0, 1, 2, 3. So that's what I'm doing. So if it's 0, if it's 1, if it's 2, if it's 3, I know it's in different states. Either it's too low, it's filling, or it's high, right? And then a timeout, of course, because things go wrong. And that's it. It's pretty simple, something that I believe that everyone in this room could accomplish themselves with just buying some off-the-shelf hardware and get to finish. And it's ugly, but it works. Let's move on. Next hardware project I had actually is the idea, the spark of this came from Calvin. He has a common problem that I think we can all identify with, and that is when you're doing laundry, you put the laundry in and you start it all up and you walk away and you immediately forget that you're doing laundry. And for some people, that's not that big of a deal because maybe the laundry is on the same floor as you, maybe you're still in the house, but he, like many of us, will forget that laundry is happening, not hear the buzzer, and then come back the next day and realize he has to run the whole thing again because it's been wet sitting in the washing machine for a day, and that's not good. It starts being kind of smelly. So he wanted some way to notify him, and not just notify him, but pester him that that the laundry was done. So I created a way. Took a simple Wi-Fi module that I bought for less than $5 and an accelerometer, a $5 accelerometer from Adafruit. If you don't know of Adafruit or Adafruit, however you say it, it's another website I encourage you to check out. Bunch of hardware, great tutorials, great learning of how to use hardware, and they have all these great little boards like this accelerometer board on the right side there, the blue one, that senses vibration or senses tilt, or I think that this one's just a 3-axis. They have 9-axis that sense gyration, and they're great. So, and I made this little board that you see on the far right just to wire them together. It's nothing but a set of wires on a PCB. The code, the only thing really here, you can see the machine library again that I'm using to interface with hardware. Here you can see me talk to Wi-Fi and how that 2 lines of code really start up the Wi-Fi, the little device as a station, and send it some SSID and password. Way easy to use to get something online to communicate via Wi-Fi. On this one, I'm using a simple service called IFT, or if this, then that. If you don't know it, I recommend checking it out. Simple service to glue things together. It's typically used for APIs, but they have a webhook section that you can send a simple get or put request to and accomplish other things. So that's what I'm using as my notification system. And this is this is all the code that it takes to get the web portion of it working. I didn't write any of this. I just copied it from somebody else because I don't care about this. Somebody else figured it out. I didn't even read this code. It just worked, so I'm just moving on. You should do the same on your projects. So just move on. So this is what I wrote, right? I'm sensing the acceleration. I actually had to set up, so there was some little complication in setting up the accelerometer itself. I'm doing a little threshold, so if it gets above a certain level of acceleration of vibration, it triggers a simple digital output. That output is what I'm reading in as an interrupt. And so if I get that, I know that the machine's vibrating. If it's vibrating for more than five minutes, I know that it's in the final spin cycle. So once that is over, then I will send a get request up to if then I can glue it to whatever I want. So I could send an email without code. I can just send an email. I can send a text message. I can send a push notification. And so it's just that simple. And that's it. That's everything. And when it's not vibrating, it's sleeping. So I'm saving some battery. Now I made this version to plug in, but it could be easily battery powered. So yeah, that's a project I think you can do. Pretty simple. Do you agree with me? Do you think you could do something that simple? Yeah. Okay. I see a lot of heads, some no's, but that's okay. Come talk to me. I'll change that no to a yes. So this one, my final project is, and I don't have much time, so I need to rush through this, but this one's a pretty cool one. It's one that, if I say so myself, I really enjoyed this one. So we have, at the office, we had a Keurig. I wanted to get an actual drip machine in there, so I brought my my dumb coffee pot from home. But you see a dumb device, that's an opportunity to make it smart, right? So I wanted to make it smart that excuse me, that I would know when a pot is finished brewing, so that everybody can rush down and get it, right? Or that I don't have to, because that's the problem. The Keurig, you just wait a minute, right? And you have coffee. This one, you got to wait 10 minutes, and then you forget, and you get onto another project, and you're like, oh, it's been an hour, and I still haven't got my coffee. So this is the setup. This is a little plug-in device that is reprogrammable. It's actually the same processor that we've seen in these last two hardware projects that you can put MicroPython on, and then you can see a little camera off to the side there. That's a AWS Deep Lens. It's essentially a green grass, almost like a Raspberry Pi, with a camera on it. It's made to run lambdas that run like machine learning algorithms. I'm not using it for that. So what I am using is the Sonoff Smart Plug. I put special firmware on. I did not write it. I just downloaded it from the internet, threw it on it. The same way that I would put MicroPython on, but instead this just does everything. So I didn't. That's not the part I wanted to play with. So it sends MQTT to the Raspberry Pi-like device, which acts as my server in MQTT language. It's a broker. MQTT, if you're not familiar, is just a communication protocol that's pretty lightweight. And so a lot of IoT devices will use it, IoT being the Internet of Things, if you're not familiar with that either. I don't know what I don't know what MQTT stands for. But it's really lightweight and it's easy to use. It's a pub-sub methodology, so a device will publish messages and other devices will subscribe to those messages that reside on the broker. And I wrote the Python script for subscribing to those messages from the sensor and then doing something useful with it. So the script will send JSON over to Microsoft Flow. Flow is another utility like IFT, but has a lot more business application, and it's I like it better. You can do more things. You can string things together, and then that will ping our business chat client like Slack, but we use Microsoft Teams instead. The camera is functional, so you can see how much is in the pot, I guess. It doesn't do anything right now. What I'm doing is sensing the current. You can see over on the right is the data that's coming from that smart plug. You can see the current's 0, then the current goes up to 8 amps, stays there for a little bit, drops back down to 0. And that's what I'm looking for, is that goes up to a high current, dwells there for a while, and then goes back down. That's called a falling edge in this world. And you can see there where I configure, it has a little web portal, so I didn't have to build that. I can configure the MQTT client. It's going to the AWS CAM. This is the code I wrote that's living on the server. It is a client. They're just living on the same machine. You can see there where I'm reading in the current from the MQTT broker. I'm checking if it's here's high current and low current. I'm checking to see if it's high. If it's high for over 5 minutes, and then goes low, then I just push a URL to Microsoft Flow. It was that easy. Now it was a free thing, which I thought was awesome because you could use it. Anybody could use it. Now it's part of the paid-for part. It's only $5 a month or something like that. So it's cheaper than other paid-for automation GUIs. So I still recommend Flow. Check it out. I'm sending some JSON. I really don't need to, but I'm saying that it's the falling edge in case I want to do something later on, say on the leading edge, just say coffee is brewing or something, rather than that it's done. And then, of course, because I'm a hack, if it fails, I just print something went wrong, you know. And then this is pretty much the code that runs all the time. So I start up the client, I subscribe to the sensor, and then I just loop forever. Loop that client forever. And that's it. Pretty easy. Flow is a GUI that lets you automate things, and so you just kind of drag and drop and configure rather than code. Kind of nice for things that you don't want to, like isn't the fun part, right? So I didn't want to do the gluing of my MQTT client to Teams, so this does the gluing going through Flow. And then when the pot is finished brewing, this is posted in our Coffee Talk Teams channel. So, and this is our administrator, so he controls everything. So that's pretty more in-depth. It uses a lot of tools I wanted to play with, but it's something that I pretty much just read off the internet and just followed along the lines, right? It tells me how to do it step by step, really easy, something you can do, something I want to encourage you to do. Be an engineer, be a hacker, go out, do projects, get them to the finish line, and then come to one of my meetups and present them. You know, I'm always looking for speakers. So, or if you need help and you haven't been able to complete that project, or there's a part you're stuck with, come to the Indy Open Tech Study Hall. It's just an evening of people hacking away at hardware and software, people helping people getting together, work on projects together. If you get something that you like, you're proud of, whatever, and you want to tell everybody about it, come to Indy Open Hardware. It's an opportunity to do a little show and tell, very similar to what I did today. And if you want to hear more about IoT and connected devices, come to Indy IoT Meetup once a month, first Thursday of the month. So thank you very much for your diligent attention. I'll stick around later if anybody wants to ask questions.
Anybody got questions for him? We'll bring the microphone over.
On the circuit boards, did you use a special application to flash the firmware?
Yeah, the chip itself that I'm using in all of these hardware projects is from a manufacturer called Expressive. The chip itself is called an ESP8266. That requires a piece of software called esptool.py. So it's just a Python script that knows how to communicate through the serial port to communicate to the chip. So that's open source, free. You can just download it off of GitHub. So, but you do need that ESP tool. Yeah.
Okay.
Anybody else?
How do you know when the coffee pot's empty and who's to blame?
That's what the camera's going to be for. So I have another engineer working on that because that's too hard for me. So he's our machine learning vision expert. In fact, he's going to be speaking at Indy IoT coming up the first Thursday of next month. So you might want to come and check that out. But he's going to figure out how to tell from using computer vision the level of the coffee and know when it gets low. And I guess we could also do facial recognition to know who killed the last of the pot and didn't brew more and shame them somehow. So